Welcome and hello. This is a tutorial video in EPANET titled Junctions. In this video, we're going to talk about junctions and explain their properties. All right, so here on the screen is the user's manual. This is the online user's manual, so I'm currently in chapter 6.4, Editing Visual Objects. And this particular chapter right here has a number of tables that goes through the different physical objects in EPANET and, for instance, lists out their properties and a description of their properties. So this table right here happens to be the properties table for junctions. So we're going to talk about the junction ID, X coordinate, Y coordinate, description, all of these, and the actual description of those properties one by one as we talk about junctions in EPANET. All right, so this table here, by the way, it doesn't word wrap. It just continues off to the right. So there's a horizontal scroll bar sort of on the bottom of this table, and you have to drag that over to the side, unfortunately, to read the description. That's just how this table is set up. So just a little heads up there. Okay, let's go to EPANET and talk about junctions. Junctions are one of the three different node types in EPANET. So the other nodes are tanks and reservoirs, and then junctions is right here. In EPANET, a junction is a node in the distribution network where pipes meet and where water demand and water quality are calculated for that location. There's two ways to add a junction to your map. First of all, you can click on the Add Junction button, and then just click on the map, single left click. I'm going to click on this Select Object button, and then click Off. So the junction was selected, highlighted as soon as I created it, but now it's not. So I can single left click to highlight that junction, and then click off to not highlight the junction. If you don't have this toolbar up here with the Add Junction button, you can add that by going up to the View menu and then Toolbars, and then make sure to toggle on Move. So click that on, and that will either appear or disappear. That's how to turn it off as well. So View, Toolbars, and Map, that's how to add it back in. The other way to add a junction to the map is to come over here to the data browser. This little browser window here has a tab for data and for map. Make sure to click data. From the drop down, select junction, which was already selected, and then click on this add new object button or add, and then boom, it's created junction 2. It says it up here in the properties box, and it doesn't appear yet on the map. And what we need to do is provide an X and Y coordinate for the junction to actually appear on the network map. So let's go ahead and put it about where my mouse cursor is right now. So 23 and 85. The X coordinate, I'm just going to type in 2300, down 8500, and down. So there is our junction 2. We want to display these junctions a little bit larger or add a label. What we can do is go up to View, Options, and then click on Nodes. And the setting here is true for all nodes, not just junctions, but also tanks and reservoirs. And then we can increase the size of the node like that. We can also make it proportional to a value, display borders, and display junctions. So we can actually hide the junctions from the network map if we want to, but I'm not going to do that. Also, to display node IDs and node values, you can go down to Notation, check on the checkbox to display node IDs, node values, and I also like to increase the font size a little bit. So I'll click on OK. Boom, the size of the junctions have definitely increased, and now we have some large labels to help us read what they are. If we want to move the junctions around on the map, there's a couple ways to do that. You can select the junction and then just drag it with the mouse cursor like that. Another way to move the junction is to open up the properties box and then just update the X coordinate and the Y coordinate. So if I wanted to move the junction over a little bit to the right, I'll just increase the X coordinate to how about 3200. So 3200, and then that's how it moves. One thing to mention is that sometimes the label gets messed up like that. So to fix that, I'll click on the pan button right here and then just move the display a little bit, and it refreshes the node labels. Okay, you saw me open up that properties box. That's the direction we're going with this lesson, is to talk about the different properties. So there's different ways to do that. You can right click, open up the properties box, close the properties box, just the red X. You can also just double click on the junction. That opens it up as well. And then over here in the data browser, select on Junctions, which is already selected. You can double click on the junction whose property box you want to open, or with it selected, click on this button right here. Okay, so here are the properties. And say, for instance, we already set the values, the property values for a junction, and we want to copy that to a different junction. We'll go ahead and demonstrate that first, and then we'll talk about the individual properties for the junction and their descriptions. So let's take elevation, for instance. Junction 2 is going to be, we'll say, 200 feet for its elevation. And if I want to copy that 200 feet to junction 1, see whichever junction I have selected is the one that I'm viewing and editing in this property box. I can also select it from over here in the data browser. But anyway, I want to copy this 200. Sure, of course, I could just type in 200 here, but if I had, say, 20 or 50 junctions that all need the same elevation, then it may be easier to just go right-click on the junction, copy, select junction 1, right-click, and paste, and now that elevation has been pasted in. So you'll obviously have more things to paste in than just elevation. There's a number of other properties that could save you a lot of time. And there's also a feature to bulk edit. So if you wanted to change 200 to 250 for both these junctions, you can just highlight those fields, right click, edit, and then do a group edit right here. I have a separate video on that, so I don't want to go off on too many tangents here, but the group editing is covered in my lesson 6 titled Object Editing. Lastly, we can delete the junction by just going right click and delete. And then I think you can also just select the junction, click the delete key on your keyboard, and it's gone. Okay, let's go ahead and add some of those junctions back in. So there's junctions 2 and 3. All right, so there we go. Let's talk about the properties finally. So I'm going to click on Select Object. Let's pick on Junction 3 here, Properties. Here is the list of properties. Junction ID is the first property. So this is a unique label used to identify the junction. And by unique means I can't call junction 3 junction 2 because that already exists. If I try to hit enter, it switches back to junction 3 on me. You saw how that worked? The junction ID can consist of a combination of up to 15 characters. It cannot be the same as the ID of any other nodes. This is a required property. So yeah, it is required. In fact, when you're looking at any of these property boxes, you know it's a required value if there's a little asterisk here by the word junction ID. See that asterisk? So the only other required property for junctions is the elevation right here. See the asterisk, but it doesn't exist for any of the other properties. Now at the very bottom, we have model results here in the yellow values. So once we have a successful calculation, we'll see numbers here. But yeah, the asterisk means it's required. And one more thing to mention about the junction IDs is that you notice there's a prefix JCT underscore. That's something that I set. If you don't see that, that's fine. You may just see 1, 2, 3, or whatever for your junction IDs, but I like to actually have this prefix here so I know that it's a junction. You can change that default. So if you go up to the project menu and then click on defaults, here in the ID labels tab, we have the ID prefix, and the first one here is junction. JCT underscore. I could just change this to say J, for instance. You may want that instead. Click this checkbox if you want that change to be saved for future projects. I don't, but I still want to demonstrate how this works for the current project. So I'll click on OK, and then let's add a junction 4. It's now J4. And then J4 is labeled right here. Okay, moving on. The X and Y coordinates are the horizontal and vertical location of the junction on the map measured in the map's distance units. If it's left blank, then the junction will not appear on the map. So we saw that earlier when we created a junction directly from the data browser. Boom, J5 doesn't exist on the map, but when we typed in the values for X and Y coordinates, it appeared. We can set the map dimensions by going to View menu Dimensions. So View and then Dimensions. And then we have our options here for map units, feet, or in meters, or degrees, or none. I think the default is none, but let's go ahead and add it feet. Okay. Next property up is the description, an optional text string that describes other significant information about the junction. So if you had something else to say about that junction, that's where you type it in. And next up is the tag. Tag is an optional text string used to assign the junction to a category, such as a pressure zone. So if, for instance, you wanted to say zone 2, that's how you do it, or zone underscore 2. It also mentions that no spaces are allowed in the tag. So you can have multiple nodes that all have the same tag, which could be used as a filter. So think of it as a class identifier. All right, after that, we have elevation. So we talked about this already. This is the elevation of that junction. Elevation is required, and it's the elevation in either feet or meter above or below a vertical datum. So I know that this is in feet because my units for the system are in feet. You saw me set it to feet. And I'm also using gallons per minute right here for my flow. So if I'm using English units, imperial units, then the elevation will be in feet. I know that the units are not displayed in this table here. So it's something that I think you just kind of have to get used to when working with EPANET. But if you were working with, say, liters per minute or liters per second for your flow, and you're using metric units, then the elevation would be in units of meters. Where you change your hydraulic flow units is in options menu and then hydraulics. It's this first one here, flow units. So currently I have GPM set, but you can use cubic feet per second as well. That's also English, or like liters per second, liters per minute. There's a few others as well. So that is how I know the elevation is in feet. The elevation is used only to compute pressure at the junction. It does not affect any other computed quantity. Next up is the base demand. So that's where we set the units in base demand. I'll say 1,000 gallons per minute. And I know it's gallons per minute because, of course, the flow units is displayed down here, gallons per minute. It's the average or nominal demand for water by the main category of consumer at the junction as measured in the current flow units. So something else to mention when talking about base demand is the next property down. That's demand pattern. So if I wanted to have a multi-period simulation, like a 24-hour simulation with a 1-hour time step, then currently it's just going to be 1,000 gallon per minute demand at my junction J4. However, in reality, there is a fluctuation for the demand at certain nodes within the water system. So you're going to want to add a pattern here under demand pattern. What the property box is looking for right here is an ID to link to a predefined pattern. So if I wanted to say J4 and then demand, then that specific pattern needs to have this exact ID, and then it will multiply whatever values are associated in that pattern with the base demand. So take, for instance, a pattern is 1, 2, 3, 4, and it's a 1-hour pattern. That means the first hour, 1, would be multiplied by 1,000 gallons per minute. And then the actual demand down here, which is calculated, would be 1,000 gallons per minute. But if the second value in the pattern, oops, here it is 2, then that would be times 1,000 gallons per minute. The second hour of actual demand would be 2,000 gallons per minute. So I'm kind of going off track here, but I do have a lesson 8 on patterns. So where you can learn more about that is lesson 8. But what you do is you go over to patterns, click on the add new pattern button, and then this pattern ID is going to be the ID that we had in our junction properties box. So J4 underscore demand. And then we just start typing in the 1, 2, 3, 4 values just like that. So I'm going to close that. I'm not going to actually create a pattern. So let's delete that and OK. And back to our junction properties. A negative demand is used to indicate an external source of flow into the junction. So if let's take the pattern off and consider it as a constant, but instead of demand into the junction, it's supply from the junction. And if it's 1,000 gallons per minute supply, that'd be constantly coming from junction 4. And just like before, you can add a demand pattern even if it is supplied. So it's almost like the opposite of demand. That's why it's a negative number right here. If the demand is blank, it's just zero demand, which is possible. You could have flow through the junction. Junctions do not have any storage, so any flow into the junction must be leaving the junction as well. I'm going to go ahead and use 1,000 GPM for my base demand. After the demand pattern, there's demand category. This is if your demand is a little bit more complicated than a single base times a single multiplier. What you can do is click on the ellipse button right here and then identify each row in this table as having its own base demand and pattern, and then you can type in a text string for the category. So the category may be industrial, residential, commercial, something else. I have a lesson 9 demand editor. I'll leave a link to that in the description. I have a whole lesson on this topic right here for this one single parameter. So I'm just going to leave that as it is. Next down is the emitter coefficient. This is the discharge coefficient for emitter, like sprinklers or nozzles, placed at a junction. The coefficient represents the flow in the current flow units, which for me is gallons per minute, that occurs at a pressure drop of 1 psi or 1 meter. And you leave the emitter value blank if it's not present. All right, the last two input fields here for the junction is the initial quality and the source quality. So the initial quality here would be, say, the concentration of chemical at the first time period of the simulation. So if it was 1 milligram per liter, for instance, at my junction 4, I'll just put a 1 right here. The units for the quality of water can be found under options and then quality right here. Our options are milligram per liter or microgram per liter. And if we are doing a chemical calculations, then you want to select parameter equals chemical. So that's how that works. I do have lessons 13 and 14 cover water quality. So a lot of callbacks to previous lessons on this one. That's how to set the initial quality. And then the source quality right here is any water entering the network at this location. So if you click on the ellipse, you have a separate dialog box where you can specify the source quality of 1 milligram per liter, 20, 50. And instead of constant value, you also have the option to apply a pattern to that concentration to that chemical, for instance, based on different source types: concentration, mass booster, set booster, and flow booster. The source quality parameter value depends on that source type, which is, again, too detailed for this lesson. So check out lessons 13 and 14 to learn more about the water quality parameters described here as source quality and the initial quality. All right, so that's it for the input fields. At the very bottom, there are a few model results, which we can look at, but not until we have a successful model run. So real quick, I'm going to go ahead and demonstrate how that works. I'm going to remove all of my other junctions and just click on delete confirmation. Yes. Okay, let's go ahead and just, I don't know, add a reservoir. And let me check the elevation on J4 here. So 0, okay, that's fine. Let me go ahead and make the reservoir an elevation or a total head of 150. And then let me add a pipe. So reservoir 1 to J4. Okay, let's go ahead and see if that works. I'll go ahead and click on run. Run was successful. So now down here in the yellow fields, we have the results for our single time period. This is the demand of 1,000 is our 1,000 base demand times 1, basically. It's the multiplicative identity there, so it's really just the same thing. 1,000 GPM is delivered to junction 4. The total head is 145.88. So this is because the total head at the reservoir is 150. And at 1,000 gallons per minute through this particular pipe, we have lost about almost 4.12 feet of head. So that equates to a pressure of 63.21 psi. And then the quality is 1, just because, oops, I left that on right here. Let me just delete that and then run the simulation again. So the quality should be 0 now. So the quality is 0, but the hydraulic properties are all the same. All right, well, that's it for this tutorial lesson video on junctions in EPANET. We showed how to create a junction, how to move it around, how to delete it, and then, of course, how to open up the properties box and describe the different properties in the descriptions.